So we're given this model here. G is equal to 2 times the cube root of t plus 46, and it's supposed to model the number of pieces of gum stuck under the desks at your high school, where t is the number of days. Something that says how many days until 100 pieces are stuck under the desk. So you plug in 100 for G, and then isolate t, cube it, and then that's your answer. Because we got to undo the cube root by cubing. So anyway, subtract 46 from both sides, and you get 54. The eraser is right behind the pause button. Okay. So you subtract 46, that's 54, equals 2 times the cube root of t. Divide both sides by 2, that's 27 equals cube root of 2. And so now we just got to undo the cube root by cubing it. So what you do to one side, do to the other. And so this is a pretty big number. It's supposed to be a t, not a 2. So you get 27 cubed. And then on the right hand side you get t. So let's see, 27 cubed. See if we can crunch that number. 1968.3. So that's 19683. I think that's last year. No, Tigers won it in 68. But anyway, so yeah, this was actually an ill-conceived problem. I was thinking that it was t cubed, so it's supposed to work out nicely, but it didn't. So let me try again. So suppose you had this model here, where this is G is equal to 12 times the cube root of t plus 24. So this will give us a more reasonable answer, because this, like if you think, just divide that by 365, and that's the number of years. So I think you get more than 100 pieces of gum stuck to a desk in a high school in 1 year, at least. But anyway, this was just a made-up problem. So let's see what we get here. So 100 minus 24, that's 76. Let's back up. I want 24 to be left over, so let's change this 24 to a 76. That'll work out better. So 100 minus 76, that's 24, equals 12 times the cube root of t. Divide 24 by 12, you get 2, equals cube root of t. And so then t is equal to 2 cubed. So t is equal to 8. Maybe that's a little bit more reasonable, depending on the school. It's a smaller number, nonetheless. So now let's just recap what we did there. We isolate the cube root, and then cube it. So it's kind of like when you're, solving a right triangle like this, and say this is x. So if you have x squared equals 3 squared plus 4 squared, you isolate the x squared, so 9 and 16 is 25, and then you take the square root. Or, better yet, let's say the hypotenuse was given, and this one was unknown. So what would you do in this case? Well, in this case you do x squared plus 4 squared equals 5 squared. You'd isolate the x squared, so you get x squared equals 25 minus 16, which is 9, so x equals, and take square root of both sides, 3. So it's the same concept of undoing an operation with its inverse.